Hello students, last time we done till here. So this is a curve like thing that is called a pulse. This is the amount of current measured for one single beta particle that is plotted against the time. So the curve is called a pulse. It corresponds to one particle when the particle entered into the detector. So the size of pulse will vary on number of ion pairs are produced and collected in the detector. So pulse size will determine the ion pairs. How many numbers of ion pairs are collected. If the more number ion pairs are collected, then pulse will be large enough. Fewer ion pairs are collected, then the pulse will be smaller. So there are 6 factors that will affect on the number of ion pairs and pulse. Number 1 factor is what type of radiation is passing through the chamber. If the radiation is of a higher specific ionization like alpha particle, then the production of ion pairs will be more. Then the large pulse will be large enough. Like alpha particle is of a high specific ionization than the gamma rays 20 times more. That will result the large pulse than the gamma radiation. So factor 2 is the density of gas that is filled in a detector. If the gas is of a more dense, then it is under a great pressure. So more ionization interactions will be available because more atoms will be available for us. So the pulse will be large enough. Factor 3, the incident energy of a radiation. How much is the incident energy of radiations? Like gamma photon of low energy, it interacts only a few times before dissipate all of its energy. That will result in a few ion pairs production. So the pulse will be small. And comparatively, if the incident gamma photon of a higher energy will interact, then it will interact many times, so it will give more ion pairs produced, so the pulse will be large enough. The 4th factor is the type of gas the chamber is filled. If the gas is easily ionized, then we will have the more ion pairs that will give the higher pulse. Generally, ion chambers are filled with a counting gas like argon. So 5th factor is the physical size of a detector. If the detector is of a small size, then gamma photon passes through it without interacting with the material. So we will not have any pulse. So conversely, अगर chamber का size जो है large होगा, then gamma photons will completely dissipate its energy inside the detector. So we will get many more ion pairs, then the pulse will be large. So the 6th factor is when the voltage across the electrodes of the chamber. If the applied voltage is low, then electron pairs that produce, they will start recombining before reaching to the electrode. So we will not get any pulse. If high voltage is applied, then gas amplification will occur. Now what is the gas amplification? Gas amplification क्या है? It is the production of the secondary ionization when the initial ions are produced by the radiations interact with gas, then the gas में जो particles होते हैं, they will produce the secondary ionization. So voltage should be high enough so that the electrons will accelerate towards the electrodes. If the electrons will gain enough energy, then they will start to produce ionization themselves. That could result in a avalanche effect. So these are the 6 factors that will affect the ion pair production and pulse. This is extremely important. अगर जो pulse produce हो रही है detector में, it is small, then the measuring device will not able to sense it. So the size of pulse can also use to determine the type of radiation, what type of radiation is entering the detector. That is called the pulse height analysis. That will tell us कि radiation कौन सी है, alpha है या beta है, by counting the number of pulses. So we can determine by the pulse that the amount of radiation, what amount of radiation is entered in a detector.